So continuing on with the second lesson of this unit where we're learning about all the cool properties of the triangle. Now, long story short, I don't have another copy of this paper, so I went old school and I just had to copy it just by hand, okay? And so your sheet should look like this. Mine's going to look a little different just because I copied it by hand. But find that sheet in your packet. Now, the key idea number one that we're going to start with is, and first thing I want to do is just take your fingers and just kind of make an angle with two fingers. I mean, you can use these two or these two, it doesn't matter. But if we were to make a triangle out of this, and we'd obviously need a third side. I mean, think about this. This kind of makes sense. If I could find something smaller, well, I'll just use my pen. I'll use my pen. So, just connecting part of this pen and making a triangle. Now, if I were to spread my fingers wider to make a bigger angle over here, it kind of makes sense that the bigger that I spread this, the longer this side across from it is going to need to be. I mean, if I went super small, I made this a very teeny tiny angle where I only need just a small piece right here. So the bigger the angle is, the bigger the side across from it's going to be. I mean, you can even take that using these two fingers because you can make a much bigger angle. Is that if we make this, and this is just more than 90 degrees, we have an obtuse angle. This obviously, the whole pen doesn't even get across there. So the bigger that we make this angle, and if we make it small, then the side across from it just needs to be so small. You can even use your hands and kind of play around with that. It's an idea that's fairly intuitive. And so what we're looking at here is the longest side, which if you look at this, you can kind of tell that AB is the longest one. Has to be across from the biggest angle. The biggest side has got to be across from the biggest angle. And in this case, the biggest angle is C. Angle C. And conversely, the shortest side has got to be across, you guessed it, from the shortest angle. And in this case, or I put shortest, that doesn't really make sense because an angle can't be short, but smallest. The smallest angle being 25. Now we may look at this and say, well, they don't really, it's kind of hard to tell their size. Right, and I just made these things up. I didn't get out a protractor, I just kind of estimated. So we're not just looking at what it looks like, but we know for a fact that if this is 25 degrees, then this has got to be the smallest side because it's across from the smallest angle. So the smallest side would be AC, is across from the smallest angle, which in this case is angle B. And so the middle side has got to be across from the middle angle. Okay, in this case the middle angle is angle A, and so the middle side has got to be BC. Okay, that's your big idea number one. And so you're going to see problems like this, where it asks you to put these sides in order. If you're on your sheet, we're here. Put these in order from the shortest to the longest. Now, first thing first, we're missing an angle. But we learned yesterday that all the angles have to add up to 180. So we'll just come over here and say, okay, 130 plus 25 is 55. And so if I just subtract that from 180, this one has got to be 25. Okay, and so here we have already example one, a little bit of a trick problem in that these two angles are the same. And some of you probably guessed this, if the angles are the same, the sides are the same. I think we talked about that a little bit in yesterday's lesson. So really this side has got to be the same size as this side. They got to be the same, which means it's an isosceles triangle. Okay, which it's not asking us to do, but we know that. That these sides have got to be the same. So the shortest side, well, it doesn't matter. AY and DA are the same. So it doesn't matter which two we put. They're the same. But the biggest side, and this is obvious by looking at it, but we know for a fact, because it's across from the biggest angle, the biggest side, the longest side, has to be DY. Okay? Now looking at example 2, it asks us to do the opposite. It gives us sides. It says put the angles in order. Okay, well, we don't have the angles. So how are we going to put them in order if we don't have them? We use the sides. Okay, we use this idea up here. And that's pretty cool. Is you can put the angles in order. You don't even know how long they are. I think that's a pretty cool idea. So we know that this is the smallest side, 10. This is the longest side. And this is the middle side. So if this is the smallest side, angle, or I'm sorry, it wants us to do large is the smallest. Make sure you pay attention to the instructions. The longest side is here, so the biggest angle has got to be angle T. And then the middle one has got to be across from here, which is going to be angle F. And then across from the smallest side has got to be the smallest angle. And so angle T, angle F, angle E. Notice how we put angles in front of the things that are angles and put a side in front and on top of the thing that's a side. That way we know what we're talking about. All right. Fairly simple, but just we got to practice that tomorrow just so you get good at it. But it's a simple idea. All right, moving on to key idea number 2. And I want to know, will any 3 sides build a triangle? I mean, think about that for a second. Any 3 sides in the world, can we make a triangle? Because the triangle just has 3 sides, but will any 3 sides build it? And hopefully you're thinking about it and you're saying, no, it's not. But I mean, let's look. I got just some objects around the house. Here's some nail clippers, a little thumbtack, and a paper clip. And if I take these 3 things, I can put them together to make a triangle. Okay, notice that I couldn't have made this angle and still made it. It's just a specific combination. I had to put it together in a certain way to get it to be a triangle. And so these 3 things make it. But watch what happens even if I just extend the little piece on the nail clippers. Is that now all of a sudden if I try to make a triangle, it's not going to close, and a triangle has to close. And even if we make this super small, I don't think it's gonna make it. It just isn't gonna close. Why is that? Well, this is too long. It's too long. But how do we know what's long enough and what's short enough? I mean, if I came in here and I brought a ruler, you know, is a ruler in this gonna, you know, here the ruler's way too long. So, you know, if I look here, I mean, it would have to be. So it's, no, not all 3 sides are going to make triangles. Now let's look at some specifics. Okay. Here's no. And if you want to draw some pictures, just to see, you know, those aren't going to close. You know, those will obviously close. Whatever, but you get the idea. Sometimes it's not going to close. So therefore, in order to build a closed triangle, because remember all polygons are closed figures, the third side has to be less than the sum. The third side has to be less than the sum and greater than the difference of the other 2 sides. Let's look at what I mean. Okay, this example, and this is what you got coming out here on your paper, is, and I can just use a sticky note. Will the following side lengths make a triangle? We got an objects 10, 4, and 7. So, you know, a paper clip, a thumbtack, whatever. 10, 4, and 7 centimeters. Will they make a triangle? Well, the third one has to be bigger. Has to be less than the sum. Is 7, and we'll just check it, is 7 less than 10 plus 4? Well, 10 plus 4 is 14. So yes, that works. But we have to check it in all cases. Is 4 less than 10 plus 7? Yep. And the last one we'll check is 10 less than 4 plus 7? And it is. Okay, and so in this case, so we just checked this part, and that's okay, is that this has to be less than the sum. By sum we mean we're adding together of the other 2. 7 is less than 14, so on and so forth. But looking over here at this next example, Is 6 less than 10 plus 3? Yes, it is. Is 3 less than 10 plus 6? So 10 plus 6 is 16. 3 is less than that. And is 10 less than 6 plus 3? Well, 6 plus 3 is 9. And 10 is not less than 9. And so 10 is too long. This is going to look like our nail clipper example where they just can't close because one of the sides is just too big compared to the other two. So if any of these does not work, then these three will not make a triangle. These will, these won't. Okay, let's look on the back. The back gives us a slightly different question. It says that 2 of them are 8 and 10. And what could the third one possibly be? Okay, so we're looking for this mystery third one. We'll just call it x. So we know x has got to be less than 8 plus 10, which is 18. So it's got to be less than 18. But if we look back over here, it also has got to be bigger than the sum. Bigger than the sum of the other two sides. Oh, I did that. I'm sorry. Telling you wrong. Bigger than the difference. That's what I wrote originally. Less than the sum, bigger than the difference. And by difference we mean subtract. So it's got to be less than the sum, bigger than the difference. The sum is 18, the difference is 2, and some of this you probably could have just done in your head, and we write it this way, that x, whatever it is, this third side, has to be less than 18, but bigger than 2. Meaning it could be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 17. 17 would work because 8 plus 17 is bigger than 10, 10 plus 17 is bigger than 8, and 8 plus 10 is bigger than 17. All of those things work. And stuff like this maybe seems confusing at first, but these are just one of those things that the more and more you practice, you'll find it is pretty easy. Okay, looking at number 4. An architect is using triangles to build the following building. This is a cool looking building. If you just Google triangles used in architecture or in buildings, you come up with there's some really cool stuff, and there's some amazing architects that use triangles in cool ways. And triangles are obviously all over the place. But looking here, right now, this guy's got building, and so let's say this is his idea, and he's got, this is 89 feet and this is 34 feet. What does that third side have to be? You know, if he's building this, he can't just create three sides and then hope that they fit together. He's going to get exact before he builds this $1 million thing. He's going to make sure his math is correct. So this third side has got to be less than the sum, but bigger than the difference. And the sum being 123, the difference being 54. So we write it and say x has got to be less than 123, bigger than 54. Okay? As always, write down your questions on the very bottom. A couple of these things may seem weird at first, but make sure you put a star by our questions and we'll practice. Or just look ahead in your classwork packet. You already have it. Look ahead and see. Well, you don't have it now, but you'll get it. Look ahead and see, what are we looking at? What do I need help with? Make sure you're doing everything you can to understand 100% of the material that we're learning.